Yeah.
Whether you have written this one?
No, sir.
No. Okay. So what I'm saying here today, what I'm going to explain you is that there are the three homogeneous. We have discussed about the homogeneous mixtures. Okay, homogeneous mixtures are the mixtures that have uniform composition. Uniform compositions. Okay, and true solution comes under this category. True solution comes under this category. Under this category. Okay, homogeneous mixtures, uniform composition, true solutions come under this category. Okay, now what is heterogeneous mixtures? Heterogeneous mixtures. We have two types of one is colloids, another one is suspension. Colloids are similar to uniform true solution almost, but they have one major difference that in in true solution if you pass a beam of light then it will not in the solution the path of light will not be visible, but in colloidal solution if you pass the beam of light then the path of the light will be visible in the solution. Path of the light will be visible in the solution. That is called true. That is called Tyndall effect. Tyndall effect. And here it is called means the true solution does not show Tyndall effect, but the colloidal solution show Tyndall effect. And suspension particles are big enough that they can be even seen with the help of naked eyes. Okay. So please start writing this one. The one major difference of this one is that, and just try to memorize this one. I will ask you, I will listen it from you. Okay. Note it down. Just start writing, please. And try to memorize it fast.
Okay.
Just a minute. Let me plug in there. Yes, are you saying something? Another students, are you saying? Please start writing this one fast. When you're done, please let me know. The particles of the true solution is so small that even with the naked eyes you cannot, means that is 10 to the minus 9 meter, that is equal to 1 nanometer. It is greater than 1 nanometer and smaller than 1 micrometer. So its particle size, it is greater than 1 nanometer. 1 nanometer to ranges from 1 nanometer to 1 micrometer, and it is bigger than 1 micrometer. Okay. Solute particle can't be seen with the help of naked eye. Here also the particle is not seen with the naked eyes. And suspension particle can be seen with the help of net. They are homogeneous. They seem to be homogeneous, but actually they are heterogeneous. And this is heterogeneous mixtures. Okay. Particles can be separated by filtration. Can't be separated. Here also they can't be separated by filtration. And here the particle is big enough that it can be separated with the help of filter paper. Transparent, they are translucent and they are opaque. Here the particles, the stable means the particles does not settle down when you keep them undisturbed. Here also the particle is stable, the solution is stable, it does not settle down. The particle do not settle down. But here the particle settle down like sand in water. When you keep it undisturbed, it particle will settle down. So please note it down. The very important is the seventh point and the first point. The both first and seventh points are very important. Sizes and this one are very important. Okay, so please note it down. That don't show Tyndall effect and shows Tyndall effect.
So can I go to the restroom?
Yeah, are you saying something?
Can I go to the restroom?
Yeah, why not? Sure.
Done.
Is there anyone still writing? Is there anyone? Okay, next is, so we have written this one. Okay. So which of the following are going to show Tyndall effect? Tyndall effect is shown by colloids or yes, okay. Means suddenly heterogeneous mixture shows Tyndall effect, that they will scatter the beam of light when we are going to have the path of light is passing through it. Okay. Now light beam is passing through it. Sorry. So next one is, if I'm talking about the colloidal solution. Okay, just concentrate. Colloids. So if I'm talking about the colloids, now the colloids, you know that when a solution is going to form solution, there must be a solute plus solvent must be there. And the state of solvent is same as that of solution. For example, if you have sugar and this is water, you mix together with sugar solution. Solution of sugar. Okay, now you see that this is liquid and here water is liquid and it is solid. So I will say that which of the following is going to be the solvent will be water because its state and this one is same, and this will be the solute. The state of the solute and the solvent, the state of the solution and the solvent must be same. Got it? समझ आया? Bari. Next one is
Yes, sir.
like for examples. Now there is dispersal phase and dispersion medium. The dispersion medium is solute and the dispersal phase. Okay, if I'm going to discuss here. So what I'm saying here is that dispersal phase and dispersal medium. Phase is solute. Dispersal phase we call it solute, and dispersal medium we call it solvent. And they when they mix together they form solution. Like for example, if you have gas, you have liquid dissolve in gas. It is called aerosol. This phase is called aerosol. And can you tell me the state of this one? If I'm saying this is the dispersal medium and this is the dispersal phase, can you tell me the state of this one? What could be the state of aerosol? Gas, liquid, or solid? Kari. So
Like,
dispersal medium and the gas, I mean the state of dispersal medium is same as that of solution. So if it is dispersal medium and it is gas, so it is also gas. Like solid, example is fog. Like solid dissolve in gas, like the carbon particles. Dissolve in gas. So here it is smoke. Smoke is an example, but it is also called aerosol. But example here is smoke. Okay, and it is that it is dry. Okay, and while fog is wet because it has liquid particles, water particles, and here smoke is having solid carbon particles present in the gas or air. We called it aerosol. Same for the emulsion. Liquid and liquid when mixed together, they form emulsion. Form liquid dissolve in we have solid dissolve in liquids. Okay, not solid dissolve in liquids. Yeah, solid dissolve in liquids and gas dissolve in liquids. Okay, this is also form like shaving cream. Okay, this is also form like we have shaving cream. Gas dissolve in solid. Let me check. I'm getting. I think gas dissolve in liquid is not form. Let me check just. So please, here we going to have this one. Form is gas dissolved in solid. I choose the dispersal medium as incorrect. That is form is solid. Dispersal phase is solid. Okay. So this is solid. Okay. So stop. So gas dissolved in solid like a sponge. Okay. And we called sponge also as the form. Okay, and we have when liquid dissolving solid. This is also formed like we can have shaving cream. Okay, so please start copying it from here. Why have you turned off your camera, everyone? Hafsa, are you there?
Yes, sir.
Alif, are you there? Alif Chaco,
Yes, sir.
why are you keeping your camera turned off? Write it down.
Okay, sir. I'm writing.
Write down the dispersal, phase dispersal, medium, type, and examples. All make this table properly, and you have to memorize this one fast.
Done, sir.
So you done, everyone? Note this one.
No. Sir, can you scroll back up one more time?
Note it down fast.
Done, sir.
Done. Noted everything. All the 8 points. It is not possible that you have noted.
No, not the bottom ones, just the top ones.
Do this one. 3, 4, 5, 6, 7, 8.
Done.
Done, everyone?
No.
Yes. Yes, sir.
Note it down fast.
Done.
Okay. So, can you tell me that what is the difference between smoke and fog? Both are aerosol. Can you tell me that what is the difference between smoke and aerosol? Smoke and fog, both are aerosol, even both are aerosol. So there is a difference between their dispersal phase. Okay, the one in fog there is liquid as a dispersal phase, but in smoke there is solid as a smell. Okay, so please note it down. Note this question in your notebook. This is an important question. Write down question number 17 and answer. Done.
Yes, sir.
No. Done.
Done, sir.
Okay. So there is some question that the sea water can be classified as homogeneous as well as heterogeneous. Comment. So can we, if the pure sea water, if it is pure sea water having only salt and water, then it is homogeneous mixture. But if it is having impurities like dust, not dust means sand, okay, other substances. So that's why otherwise it will be considered as heterogeneous. So please note down this question. Then I'm going to answer you these questions first.
Sir, all three questions?
No, only the question number 13.
Okay.
So done question. Yes, Alif, have you noted question number 13? And you, Huda, yeah, you, Hafsa, have you noted?
Yeah.
Okay, what could be the answer for this question? Question number 13. What could be the answer for this question? Alif, can you answer me this question number 13? Alif, can you answer me this question number 13?
Yes.
Can you answer me question number 13? I explained you recently. Okay. Have you noted the questions? Yes, you got it, noted?
Yes, sir.
Please write down the answer, question number 13 here. That it is homogeneous. Sea water is homogeneous when it is having only salt mixed with water, and when it is heterogeneous when it is containing salt, water, mud, neither. Okay. You done?
Done, sir.
So you also, Hafsa, have you noted?
Yeah.
So next question is that explain why the particles of colloidal solution do not settle down, because they are not big enough and they're not having much mass. So okay, so the particles of the colloids are small in size, that's why they do not settle down. Otherwise the particles of heterogeneous mixtures, other heterogeneous mixtures like suspension, settle down because they are big enough. Okay, so they left undisturbed. Why they do not settle down? Because otherwise they could settle because the size is small. Okay. While in case of suspension, they do. Just because the particle size of suspension is big enough that it can settle down. So write down the question 16 and then I'm going to help you to write the answer. Write down on the question 16 fast.
Done.
You done? Okay. So please note down the answer for this question. The particle size in suspension is large than those colloidal solution. Also, the molecular interaction in suspension is not stronger. Means molecular interaction is not stronger to keep the particle suspended. Okay, hence they settle down. But in colloid, the molecular interaction is good, so they keep the particle suspended. Okay. You done? Noted. Question number answer number 16. Note it fast.
Done.
Done, everyone?
Yes, sir.
Okay. Now, can you tell me that how many of them are compounds in the following? Compound. Can you tell me that which of the followings are compounds and element? Is Cu is compound or element? Cu, compound or element?
Element.
Yes, it is element. This one sand,
Compound.
we'll say, yeah, we can say, but it does not have any specific formula. So classify the substance given into elements and compounds. So sand have many impurities, so we cannot have any formula for the sand. So it is a mixture. Next one, calcium carbonate, compound or element?
Compound.
Yes, it is compound because it is having more than one types of atoms like calcium, carbon, oxygen. Diamond,
Element.
yes, diamond is an element because, and which element it is? It is carbon. Diamond is an element, it is carbon. Mercury, Hg, Hg is mercury. Is it an element or compound?
Elements.
Yes, it is the element. F2, F2,
Element.
yes, it is element. O2,
Element.
element. Zinc,
Element.
okay, it is an element. NaCl aqueous, it is aqueous, it is mixed in water, so that's why it is mixture. Okay, AQ means in water. So NaCl is a compound, but it is when it is dissolved in water, it is a mixture. And wood is also a mixture. Okay, so please write down these all in your notebook and write down whether they are mixtures, element, or when you're done, please write.
Yes,
You done?
No, sir.
yeah.
Done, sir.
Oh, now,
Done.
okay, now we shall be going to study a different topic, that is concentration terms. Okay, so there are the three concentration terms. Like for example, if I'm and what is the use of concentration terms? Let me explain you first. Like for example, if you have a glass of water and it is having, this is a glass of water, this is a glass of water, and it is having 250 ml of water, and you add or 250 gram, let's call it 250 grams of water. Okay, and then you add you add 50 gram of sugar to it. 50 gram of sugar to it. 250 ml of water. Okay. Now another you have a bucket. You have a bucket, and in that bucket, okay, you have 5,000 kg or gram, 5,000 gram of water. 5,000 gram is 5 kg of water, and uh you added 1 kg of sugar to it. 1 kg means 1,000 grams. So can you tell me that which, if you take a sip of water, okay, from both, can you tell me that which will you will feel that it is going to have more sugary, or we can say more sweet in taste? Bucket, or the bucket solution, or the glass solution?
Glass.
Glass. Glass will be more. Another? Yes, you got it. Will the bucket will
Yeah.
if you taste a sip of water from both bucket and the glass, which you think that it is more sweet? You have in glass you have 250 grams of water. Okay, and in 250 grams of water you have 50 grams of sugar. Okay, and here you have 5 kg of water, and you added 1 kg of sugar to it. And can you tell me that which do you think is more sweet?
Glass.
In glass. Okay. So that is going to help us. This is a concentration term that which comes into play, and which will tells us that which is going to be more sweet or more concentrated. This is the concentration terms. Okay. What are the concentration terms? Don't write अभी हम like समझाने देते हैं. Okay. What is the concentration term said? That mass of solute upon mass of solution into 100. So let's check which is going to have more. Mass of solute in the bucket is 50. Sorry, in the glass is 50. Sugar is solute, okay? And the mass of solution is 50 plus 250. 50 gram is sugar mass, and 250 gram is the water mass. So both when added, they will form solution. The mass of solution is 50 plus 250. 50 plus 250. They are the two terms, so they cannot cancel out each other. कभी काट दो इसे. Okay. So it will be 50 into 100. 50 plus 250 into 100. Okay, that would be equals to 50 into 100 upon 300. Okay, you cut with zeros, you will get 50 by 3. Okay, 50 by 3 is approximately 16.33. 16.666%. Okay, now check the concentrations of the bucket. Now bucket have 1 kg means 1000 grams of sugar, and the solution will be mass of solution will be 100 upon, sorry, 1000 grams is sugar plus 5000 grams is water. Total is 6000. 6000 grams. So you will use 6000 into 100. So you cut it. Okay. Here you get 100 upon 6. You will get 50 by 3. Okay. Still 50 by 3 is 16.666. So both are equivalent. Both are equivalent. We will taste if the concentration of both of them are same. So we'll say that the both will going to have the same taste. Okay. So 50 by 3 here, 16.66 percentage here. There also the if the concentration of uh, glass is more, then it will be more sweet. The concentration or the percentage of the bucket is more, then it will be going to have more sweet in taste. Okay. So here, this is the concentration term that comes into play. So what is there? The three types of concentration terms. One is mass by mass percentage, mass by volume percentage, and volume by volume percentage. So please note it down. What is mass by mass percentage? Mass when X gram of solute dissolved in 100 grams of water. Okay. That is called mass by mass percentage. In short, we write W by W. Mass by mass percentage is W by W. And please note it down fast. To do it, please fast.
Yeah.
Done, sir.
Yes, are you saying something? You done?
Sir.
Yeah, I'm
No,
listening.
sir.
तो लिखो फटाफट से. When you done? Are you saying something?
No, wait, I'm not done with.
Okay, okay, do it. Done?
Yes.
Yeah.
Okay. So here is the question. Calculate the mass by mass percentage when 30 grams of sugar is dissolved in 300 ml of water. Please note down this question only. Fast. You done?
Yes, sir.
So what could be the answer? When 30 gram of solute is dissolved in 300 gram of water. Can you tell me the answer? What is mass by mass percentage? What is the formula, Gauri? What is the formula for this one, Gauri?
Mass of solute by mass of solution.
Yes, mass of solute upon mass of solution into 100. Into 100. Okay, now mass of solute is? Solute is? Can you tell me the mass of solute?
Solute of solution, that 30 gram solution.
30 upon mass of solution is 30 plus 300. This is the mass of solution, that is 330 into 100. You cut 1 0 with 1 0. Okay, you can get 10 and you will get 11. Then this 10 multiplied with this 10, you will get 100 upon 11. You get 9.09%. समझ आया?
So won't it be like 1 instead of 10?
Where? 10 into 10. You can cut it 330 upon into 100. You can cut 1 0 with 1 0. You will get 1 za. You can write 11 and then you can write it 100 upon 11 because 100 is in the formula.
Okay, okay.
You done?
Yes.
Okay.
Yeah.
Just a minute. Okay. Calculate the mass of sodium sulfate required to prepare. Write on question number 42. Please fast. Question number 42. Please note it down fast. When you're done, please let me know. Noted question number 42.
Yes, sir.
So what is saying, if the mass by mass percentage is 20 and present in 100 gram of water, it is not solution, 100 gram of water. So mass of solvent is water. Okay, that is 100 gram. Mass of solvent, which we water, is 100 gram. And mass of solute, it is being asking. So you write X. Okay, now what do you write here? You write X is equals to X upon, sorry, 20. Mass by mass percentage. Like W by W percentage is equals to mass of solute upon mass of solution into 100. So you know that it is being given to you W by W percentage, 20%. So that 20 is equals to X is the mass of solute, and mass of solution will be X plus 100. Because X should be added here. 100 gram is not solution, it is solvent into 100. Okay. Now this as a whole quantity will goes to this side, and this 100 will multiply with this X. So you will get 100X is equals to 20 in bracket X plus 100. You will get 20X, and this bracket is going to multiply with this one, and you will get 2000 is equals to 100X. Now this is going to, this 20 will comes to this side, okay, and you will get 80X, because 20 and subtracted from this one, you will get 80X is equals to 20,000, and X will be equals to, right, X will be equals to 20,000 divided by 80. You got it? You will get X is equals to this one. Okay, understood? समझ आया?
Yes, sir.
Yes.
So you got 20 by 200 by 8, you get 25 grams. So please copy this one. Mass of solute is 20 grams, 25 grams.